The third question is, what is the probability that both the ants will meet? Ant 1 can move one step right or one step up, but a total of 8 steps. Ant 2 can move one step left or one step down, but a total of 8 steps. What is the probability that both the ants will move? Pause this video, come back to me with the solution. Now, this is a question I was excited about when I had solved during my JEE prep back in 2008. We have an ant A1 here and an ant A2 here. What I am essentially trying to say is, the first ant has 8 steps and the ant is going to do as per whatever order: right up, right up, right up, right up. This is one of the arrangements that the ant can follow. If we have to break down the total number of ways the first ant can move, I can say that the ant, out of the 8 steps, it can choose 0 ups, or it can choose 1 up, or it can choose 2 ups, or it can choose all 8 ups. So this is the total number of ways that ant A1 will be able to move, and from binomial expansion we know this is equal to 2 power 8. So this is for ant A1, and by symmetry we can say ant 2 is also 2 power 8. So the total number of ways both ant A1 and A2 will be able to move is 2 power 8 into 2 power 8, which is 2 power 16. I hope the total number of ways is clear to us. But the catch lies in identifying, out of these 2 power 16 ways, in how many ways do both the ants move. If we try to observe the ants and think about the motion, we will identify that it is possible for both the ants to meet only along my diagonal squares, and it is not possible for the ants to meet along any other square, because let's say ant A1 moved one step up and 7 steps right, it would end up here. But if the ant A2 moved 8 steps down, it would end up here. But that is not allowed. The only way the ants will meet here if A1 moved one step up and 7 steps right, and A2 moved 7 steps down and 1 step left. And that is how we find the total number of ways in which the ants will move, which is equal to, if the ants have to move, I am going to write it on the chessboard itself. If the ants have to meet in this square, it is going to be 8C0 into 8C0, because this ant has to just move up, means 0 steps right, and this ant has to move left, means 0 steps down. This is going to be 8C1 into 8C1, because now A1 has to move one step right and 7 steps up, which is out of the 8 dashes, choosing any one for right and the remaining up. If the ant moved up, 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 up and right, it would end up there. If the ant moved right, up, 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 it will end up there. And that how? Same way, 8C2 into 8C2, 8C3 into 8C3, and so on 8C8 into 8C8. Out of the 8 blocks, all the things are right, and out of the 8 blocks, all the things are down. So the total possible ways where both the ants will actually meet is summation I equal to 1, 0 to 8, 8ci whole square. And the answer or the probability is going to be summation 8ci the whole square by 2 power 16. And that is the answer. Let's see how we can do the 8ci whole square. Now doing 8ci whole square is also very interesting. Now, as we know, NCR is equal to NC n minus R. So, I can write this as 8C0 into 8C8 plus 8C1 into 8C7 plus 8C2 into 8C6 plus so on plus 8C8 into 8C0. And this is a combinatorics question. Let's look at a way of doing this. Let us say we have 8 boys and 8 girls, and out of a total of 16 members, we have to choose 8 members. This can be broken down into choosing 8 boys and 0 girls, or 1 boy and 7 girls, or 2 boys and 6 girls, or 3 boys and 5 girls, and so on, which is nothing but this expansion. So using combinatorics, I can say that this is equal to 16C8, which means in a class of 16 students, out of which 8 are boys and 8 are girls, I have to end up choosing 8 students irrespective of the number of boys or girls that are chosen. And hence, the answer would be 16C8 by 2 power 16 is my answer.